So let's take a look at an example, and we're really just doing a lot of the same things we've done before, because once again our formula is pretty much the same, right? If we're looking for velocity, that's going to be the derivative, right? If it's instantaneous velocity, it's going to be the derivative, and so we're going to be using the same formulas, just in a different context. All right, so it says here a lead weight on a spring. So we have a lead weight on a spring is oscillating up and down. Its position at time t with respect to a fixed horizontal line is given by s of t equals sine of t. Use a table of values to estimate v of 0, and check the estimate by using the equation. All right, so we'll use equation 3.5. This is the one that I put on the other page. Not the one I'll use most of the time, but with velocity and when we're talking about the the secant line versus the tangent line, it is a little more intuitive, I think, to think about the slope formula, and so we'll use this one for right now, and then we'll use t instead of x. So as t approaches a, it'll be f of t minus f of a all over t minus a, right? And so we'll use that one for this one, and this will be our the derivative of position, also known as velocity, right? The derivative of position at a, or the velocity at a. Okay. All right, and so this time a is going to be 0. All right, so let's plug in some values. All right, so, and one thing I should change here is these are, I made these f of t, but they should be s of t. All right, and so if we set up our formula, we're gonna be approaching 0, not h, but as t approaches 0, and this is gonna be s of t minus s of 0 all over t minus 0, right? So this is sine, right? S of t is sine of t. So so I'm just going to put sine of t here, because that's what s of t equals. All right. And then here for s of 0, that's going to be sine of 0. And if you know what sine of 0 is, you can do this on your calculator, but sine of 0 is 0. Okay. You can also look at your unit circle or exact values table. That's going to be 0. And so what we end up with is the limit as t approaches 0 of sine of t minus 0 over t minus 0, right? Which is really just sine of t over t, right? And so if we plug in 0, we get a 0 over 0 situation, right? And so so what we'll do here is use a table, although you could, there are other ways we could do it, like graphically and things like that, but we'll do a table. So I'm going to plug this in to my calculator, and then I'm just going to evaluate at these values here, right, until I can kind of see a pattern. And of course here I'm approaching 0 from the left. All right, so I plug in 0.1 and I get 0.998342. 3342. All right, so now I'm going to plug in 0.01 and we get 0.9999833. Okay, so we just basically put a few nines in front here. All right, let's see what happens if we put in 0.001. Okay, and in this case, it actually says y equals 1, so that means it's so close to 1 that it can't differentiate between 1 and the decimal value here. Okay, so it's essentially 1, and this is still not exactly 1. It's just that our calculator doesn't have the precision or the available decimal space to put enough decimals, to get the approximation there. Okay, and so we can see from the left we're approaching 1. Okay, so now let's do the same thing from the right. So let's plug in values to this here that are close to 0 from the right. So those would be values like, and I should have put negatives here. So actually this was from the right, and this should be from the left. All right, so negative 0.01, sorry, negative 0.00, or negative 0.01, negative 0.001, and so forth. So let's see what we get. All right, and we get, in this case, 0.9983342. That might look familiar because that's what we had here. So I'm assuming the next one's going to be this and then this, right? All right. Turns out we get the same thing as we got here, right? If we plug in negative. So we get 0.9999833. All right, so what do you think this one will be? And you got it, yeah, so close to 1, our calculator can't differentiate. And so that's approaching 1, so it's approaching 1 from either side, which means that that it's approaching 1, right? So the limit as t approaches 0 of our function here is gonna equal 1. Okay, so that means that the velocity at 0 equals 1. Or we can also say the position, the derivative of the position at 0 equals 1, right? All those mean the same thing.